Hello! In this Coolgrad video, we're going to talk about data sufficiency. So these are a very important type of questions in the quantitative section for GRE and GMAT exam preparation. So in the data sufficiency problems, we're going to go over about 80 questions here, and we're going to study each problem, and each of the questions will have 4 different options. So they will have 2 statements, and you're supposed to evaluate if either statement alone can answer the question, or both the statements together can answer the question, or even using both the statements you cannot answer the question. So this is what data sufficiency is all about. And this is a very critical part of the quantitative section. So let's take a look at some data sufficiency questions. So basically, for every question you have to choose the answer as 1, 2, 3 or 4. So option 1 is when the question can be answered by one of the statements alone but not by the other. So there's 2 statements, A and B. So either A alone can answer the question, or B alone can answer the question. But if A can answer the question, B alone cannot answer the question. And if B can answer the question, A cannot answer the question. That's what this means. So remember, option 1 means either of the statements alone can answer the question, but the other one cannot. So only one statement alone can answer the question. So remember that. Option 2 means the question can be answered by using either statement alone. So using A or B alone, you can answer the question. Either A alone or B alone. Both work. So that is option 2. Option 3 is when you can use both the statements together to answer the question, but you can't use either statement alone. And option 4 is when you can use both the statements together and still not be able to answer the question. So this is what data sufficiency is all about. And we're going to evaluate some classic examples of the type of questions that are asked in this section. So let's take a look at our problem number 1. Find the product of 4 distinct prime numbers, A, B, C and D. So A, B, C and D are prime numbers. That's all we know from the question statement. And from statement A, the sum of the 4 numbers is 17. Statement B, the product of A and D is 1 less than that of B and C. So let's try and work out the solution. So using statement A, what do we know? We have to find 4 prime numbers whose sum is 17. So let's list out all the prime numbers between 1 and 17. So we have 1, 2, 3, 5, 7, 11 and 13. So which 4 of these numbers together can add up to 17? So 2, 3, 5 and 7. So 2 plus 3 plus 5 plus 7 gives 17. And there's also one more set, that is 1 plus 2 plus 3 plus 11. This also gives 17. So there are 4 sets, there are 2 sets of 4 prime numbers which satisfy this condition. So using A, we don't know which the 4 numbers are. So A alone is not enough to answer this question. Let's look at statement B alone. Using B, multiple sets of prime numbers satisfy this condition. So we just have to have 4 prime numbers such that A times D is 1 less than B times C. So for example, 2 times 7 is 14 and 3 times 5 is 15. So 2, 7, 3 and 5, they meet this condition. And you can also have another set, for example. 3 times 7 is 21 and 2 times 11 is 22. So that's another possible answer. So you can't arrive at a unique solution using statement B alone. So option 1 and option 2 are ruled out because you can't solve this problem using either statement alone. So let's try using both these statements together. So using A, we have potentially these 2 solutions. Using B, we have these 2 solutions or some more. So using the intersection of these 2, we see that 2, 3, 5 and 7 is one possible solution. It's in fact the only solution to all the conditions given here. So using A and B together, we find the unique answer as 2, 3, 5 and 7. Those are the 4 prime numbers. So the option would be 3. We use both the statements together. So that's how you solve this problem. So question number 2. If x and y are positive integers and y is an even number? That's the question. So all we know is that x and y are positive integers. Statement A, 4x plus 3y equals 26. Statement B, 3x plus 5y equals 25. So let's look at statement A alone. So 4x is an even number, right? 4 times any positive integer is an even number. 4x is an even number, and so 4x plus 3y is also an even number. So therefore 3y must be an even number, right? Because an even number, only when it's added to another even number, gives an even number, right? So 3y cannot be odd. So 3y must be an even number. So 3 times only an even number will give an even number, right? So we can confidently say that y must be an even number. So using statement A alone, we can say that y is an even number. So statement A alone can solve the problem. Now let's look at statement B. If you try to substitute various values of x and y ranging between 1 and 5 in the equation, you will see that y can take only the value of an even number, y equal to 2. So for this equation, these are all small numbers, right? X and y. So we try and substitute various values. So suppose you substitute, say, y equal to 1. Okay, so this becomes 5y is 5, and 3x plus 5 equals 25. So 3x equals 20. So you can't have an integral value of x. So y is equal to 1 is ruled out. So try y equal to 2. When y is equal to 2, so we have 3x plus 10 equals 25. And so 3x is 15 and x can be 5. So you have a solution where x is 5 and y is 2. Now let's try y equal to 3. So 3x plus 15 equals 25. So 3x equals 10. And you can't have an integral solution for x. And say y equal to 4. So 3x plus 20 is 25. So 3x is equal to 5. And you can't have an integer value for x. And if y is equal to 5, 3x plus 25 is 25. So 3x is 0. So that doesn't work either. So the only integer, positive integer that satisfies this equation is y equal to 2 and x equal to 5. So by substituting values, you can find the unique solutions using A or B alone. So either statement alone is enough to solve this problem. So we pick option 2. So sometimes students, the moment they see two variables like x and y here and then x and y here, instinctively they think that they have to use both the statements together to solve, there are two variables, two unknowns, so you have to have two equations, and immediately they pick like option 3. So sometimes by just plugging in values, you will see that you'll be able to solve these equations with two unknowns. By just plugging in some values, you can determine that there is a unique solution once you know that they're positive integers. So, and we don't even have to solve for the value of y. We just have to determine if y is an even number. So using either statement alone, we can answer that question. So we pick option 2. So that solves this problem. Let's look at question number 3. How many football coaches and players are there in a group of 50 people if each person is either a coach or a player? So there's a group of 50 people, and they're all either coaches or football players. So statement A, if each coach offered a cookie to all the players and each player offered a chocolate to every coach, there would be a totally 800 items offered. B, statement B, the number of players is 4 times the number of coaches in the group. So using statement A alone, if there are X number of coaches and Y number of players, so X number of coaches offer cookie to Y number of players. So each of the coaches offers a cookie to each of the players. So how many cookies are exchanged? X times Y, right? XY. And then Y number of players, each would give a chocolate to X number of coaches, to every coach. So YX number of chocolates would be exchanged. So XY plus YX, total number of items offered would be XY plus YX equals 800. So 2XY is 800, or XY is 400, So either x is equal to 40 and y is equal to 10, or vice versa. So or we can also or we can have x is equal to 10, y is equal to 40, or we can also have, say, x is 20, y is we can't have x is equal to 20, y is equal to 20, because even though 20 times 20 is 400, the sum of x and y must be 50, right? There's totally 50 people. So either it's 40 players and 10 coaches, or 10 players and 40 coaches. We don't know which. I mean, using common sense, you can guess that the number of players will be more than the number of coaches. So, but we can't make that assumption here. So, using statement B alone, we can arrive at number of players is 4 times the number of coaches in the group. So, using statement B alone, so there's totally 50 people. Okay? So, players plus coaches is 50. And players is 4 times the number of coaches. So 4 times the number of coaches plus the number of coaches equal to 50. So 5 times the number of coaches is 50 and the number of coaches is 10. So using statement B alone, we can say that the number of coaches is 10 and the number of players is 40. So B alone is enough. And using A alone, we can't determine if the number of coaches is 10 or the number of players is 10. So A alone is not sufficient, but B alone is sufficient. So we would pick option 1, because this can be answered by one statement alone but not by the other. So question number 4. Who among P, Q, R and S is the tallest? P is taller than Q and S. And statement B says R is taller than Q but not as tall as S. So remember, there are 4 people. We have to determine who is the tallest. Using statement A alone, we know that P is taller than Q and P is taller than S, but we cannot determine the height of R. So we definitely know that P is taller than Q and S, but what about R? We don't know. So A alone is not sufficient. Using B alone, R is taller than Q but not as tall as S. So S is greater than R is greater than Q. So we know that S is greater than R greater than Q, but we cannot determine the height of P using the statement B alone. So using both the statements, we know that S is greater than R greater than Q and P is greater than S. So P must be greater than S greater than R greater than Q. So we can say that P is the tallest. So using both the statements, we can answer the question. So for question 4, option 3, both the statements are needed to answer the question. Question number 5. If A, B, C and D are positive integers, is A greater than B? The product of C and D is A. That is statement number A. So A, B, C and D are positive integers, okay? And we have to find out if A is greater than B. Statement A, the product of C and D is A. Statement B, the product of A, C and D is B. Using A, so all we know is C times D is A. So don't be tempted to think that A must be greater than C and D. Okay, because we don't know if A equal to B equal to C equal to 1, right? They're all positive integers still. It doesn't say that they are unique, okay? So 1 times 1 is 1, right? So that's also possible. Using A alone, we cannot say if A is bigger than C or D. And we still don't know about B. Using B alone, product of A, C and D is B. So it might be tempting to think that B must be the biggest, but what if they're all equal to 1? So if we put, using both the statements together, if you substitute C times D is A, so A square equal to B. It looks like B is the biggest, but still you don't know if A equal to B equal to C equal to D equal to 1. So using both the statements together, we cannot answer the question. So option 4. Question number 6. Is P equal to P cube? So statement A, P is an integer and a perfect square. Statement B, P equal to 1 or P equal to minus 1. So let's look at statement A alone. Remember that integer can mean positive or negative integer. But as P is a perfect square, P must be positive. So P is an integer, but it can be a positive or negative integer. P is a perfect square, so P must be positive. So P is a perfect square. So the number is a perfect square, and also all we know is the number is a perfect square and an integer. So that's not enough data to say if P equal to P cube. So P is an integer and a perfect square. So P can be 4 or 9 or 16 or 1. We don't know. If P is equal to 1, then P equal to P cube. And if P is equal to 4, then P is not equal to P cube. So we can't arrive at a unique solution. Using statement A alone, we cannot solve the problem. Let's look at statement B alone. It says P equal to 1 or P equal to minus 1. So either way, P equal to P cube, right? So 1 is equal to 1 cube. And minus 1 is equal to minus 1 the whole cube. So either way, P equal to P cube, whether it's 1 or minus 1. So statement B alone is sufficient to answer this question. But statement A alone is not sufficient. So we would pick option 1, which means one statement alone is enough to answer the question, but the other statement cannot answer it. So option 1. So plug in values in such questions and try to solve the problem. Question number 7. Is x greater than y? Statement A, 1 by x is greater than 1 by y. Statement B, x square greater than y square. So using statement A alone, we directly infer that if 1 by x is greater than 1 by y, so regardless of whether they are positive or negative numbers, y is greater than x. Directly we infer, and therefore x is greater than y. And therefore we can answer this question. Statement A alone is sufficient. Let's look at statement B alone. X square is greater than y square. So x and y may be positive or negative numbers. So suppose we use statement B alone. Suppose x is minus 3 and y is minus 2. So x is less than y, right? But minus 3 the whole square is 9 and minus 2 the whole square is 4. And 9 is greater than 4. But x is less than y. And if suppose they are positive numbers, x is 3 and y is 2, then x is greater than y, and this condition still holds. So using this information alone, we cannot answer if x is greater than y. But using A alone, we can answer the question. So statement 1, option 1. Statement A alone is enough, but statement B alone is not enough. Question number 8. Is xy greater than 0? X and y are integers such that x plus y is equal to 5. Statement B, x is greater than xy. So using A alone, x and y are integers, but we do not know if they are positive or negative integers. So if both of them are negative integers, the condition would still hold. X times y would be greater than 0. If one is positive, the other would be negative, then it doesn't hold. So we say integers, be very careful. They can be positive or negative integers. So it says x plus y is equal to 5. So x can be, for example, minus 8 plus 3. Minus 3 plus 8. We get 5. Right? So if x and y are positive, xy is greater than 0. Else xy is less than 0. So just because it says x plus y is equal to 5, we still don't know whether they are positive or negative integers. X plus y is 5, so therefore at least one of them must be positive. But the other one might still be negative. For example, if let's say y is 7, so x will be minus 2. You'll still get the answer. So, or if you can say 4 plus 1 is 5. So both may be positive, one may be positive, other one might be negative. So we still don't know. But let's say we use statement B alone. Y is less than, x is greater than xy. So you cancel x on either side. So you get 1 is greater than y, and so y is less than 1. Directly you get it from the statement. Y is less than 1. Using b alone, we do not know if x and y are integers or can be any real numbers. But in statement b alone, it doesn't say whether they are integers or any real numbers. So y is less than 1. So what if y is equal to 0 or y is equal to 0.5? We don't know, right? So using b alone, we don't know whether they are integers or not. So we can't say if it's greater than 0. It only says y is less than 1. But we still don't know the value of x. So either statement alone is not sufficient. But what if we use both statements together? Using both the statements together, y is an integer less than 1, right? From using b, we have y is an integer and it's less than 1. So y is either 0 or a negative integer, right? So using statement b, we have y less than 1. And using statement a, we have y is an integer, right? So y must be either 0 or -1, -2 or something like that. Either 0 or a negative integer. So regardless of whether y is 0 or a negative integer, x times y will be 0 or less than 0, right? But I mean, so if let's say if y is 0, then x must be 5, right? If y is -1, x will be 6. Y is -2, x will be 7. So x will be 5 or greater than 5, right? So we know that x is a positive number and y is either 0 or a negative number. So positive number multiplied by 0 is 0. Positive number multiplied by a negative number will be negative. So either way, xy will be less than 0. Using both the statements together, we can answer this question. So we pick option 3. Data sufficiency number 9. What is a 2-digit number? So statement A, the difference between the 2 digits is 9. Statement B, the number is a multiple of 10 and contains one of the digits as a perfect square. So using statement A alone, let's try and solve this. The difference between the 2 digits is 9. So it's a 2-digit number. So suppose you have 81. 8 minus 1 is 7. If 80, 8 minus 0 is 8. The only way you have the difference between the 2 digits as 9 is when you have 9 and 0, right? You cannot have 0, 9 as a number because it's a single digit number. So you must have 90, 9, 0. 9 minus 0 is 9. So the number can only be 90. So using A alone, we can solve the problem. Let's try using B alone. The number is a multiple of 10. It's a 2-digit number, multiple of 10. So I say the 10, 20, 30, 40, 50, 60, 70, 80 or 90. So it can only be these 9 values. And contains one of the digits as a perfect square. So that we know the unit digit is 0. So the 10th digit is a perfect square. So it can either be 1, 4 or 9. So the number can be 10, 40 or 90. We don't know which one. So B alone is not sufficient, but A alone is sufficient. Sometimes students may get confused and say both the statements are needed, but no, A alone is sufficient. So when you are solving data sufficiency problems, try and evaluate every possible way to use one statement alone to solve the problem. Plug in values, do whatever you can, and see if that statement alone is enough to solve the problem. Then go to the other statement alone and see if that alone is enough to solve the problem. And only when both are not enough, then you go to option 3 or option 4 to solve. A alone is sufficient, but not B alone. So we pick option 1. Question number 10. What is the cost of an eraser? Statement A. The cost of 12 pens, 8 pencils and 15 erasers together is equal to rupees 3,700. So B. Statement B. The cost of 3 pens, 2 pencils and 7 erasers together is equal to rupees 1,250. So there are 3 variables and 2 statements. So Sometimes it might be tempting to think that, you can solve two variables using two equations, and if you have three variables, you might need three equations, but that's not true. Because here, 3 times 4 is 12 and 2 times 4 is 8. So you just multiply this equation by 4. For example, using statement A alone, we have 12A. Let's say pens are represented by variable A, B, and C. Okay, so 12A plus 8B plus 15C is equal to 3700. And using statement B alone, 3A plus 2B plus 7C equals 1250. So you just multiply this by 4. So you get 12A plus 8B plus 7 times 4 is 28. 28C is equal to, this number multiplied by 4, which is, I guess, around 5000. So we have 28C, and then you take the two equations together. These two variables will go directly away, and you get 28C minus 15C is equal to 5000 minus 3700. So if you just plug in, you can solve the value of C. And C is the number of erasers, so you get the answer directly. So using both these statements together, we can solve the problem, but not using either statement alone. So even if you try to plug in values, like, for example, you say C is equal to 1, and you can have multiple values for B and A. You can have multiple solutions even if you try plug in values. Even using this statement, for example, suppose you put A is equal to 1, you can have multiple values for B and C. So you don't get a unique answer. But using both the statements together, you can get unique answers. So, question number 11. How old are John and Peter now? When John was 6 years old, Peter was 4 times his age. So, statement B, Peter will be 27 next year. Using statement B alone, Peter's current age is 26. So, using statement B alone, we only know the age of Peter. We don't know the age of John. So, clearly statement B alone is not sufficient. Using statement A alone, when John was 6 years old, Peter was 4 times his age. So, Peter was 24. So, we got that. Okay, but using this statement A alone, we cannot solve the problem either, because we don't know how old Peter is now or how old John is now. So when was John 6 years old? How many years ago was that? We don't know, right? But using both the statements together, so when Peter is now 26, so when Peter was 24, John was 6. Peter is now 26, so it's 2 years ahead. So John will be 6 plus 2. John will be 8 years old. So John is now 8 years old and Peter is 26 years old. So using both the statements together, we can solve for their age. So we pick option 3. What is the area of the rectangle? The perimeter of the rectangle is equal to its area. And statement B, the length of the rectangle is twice its breadth. So we have to find the area of the rectangle, which is length times breadth. Using statement A alone, if length equal to A and breadth equal to B, so 2A plus 2B is the perimeter. That's equal to the area AB. So we just know this, and we don't know the individual solutions. It can have potentially multiple answers. Using statement B alone, the length of the rectangle is twice its breadth, so A is equal to 2B. Using both together, we can solve and get A is equal to 6 and B is equal to 3, and the area must be 18. So even if you try plugging in values using A alone, okay, this equation probably has, I'm guessing, two solutions, which is either A is equal to 3 and B is equal to 6, or A is equal to 6 and B is equal to 3. So even if you have only those two solutions, we don't know whether A is equal to 6 or B is equal to 6. We still don't know that, even if you try plugging in values here. And A is equal to 2B, but we don't know anything about the perimeter and the area. So using both together, we get unique solution. So A is equal to 6, B is equal to 3, and the area is 6 times 3, that is 18. So option 3, we need both the statements to answer this question. Data sufficiency question number 13. How many Fridays does February of a certain year have? So Statement A, the 5th Tuesday of February is a holiday. Statement B, the 6th of February is a Sunday. So let's try using statement A alone. So it says the 5th Tuesday of February is a holiday. So February has 5 Tuesdays. So in a regular year, February has 28 days. And in a leap year, February has 29 days. Suppose it has only 28 days. So a week has 7 days and it has 4 weeks. And a certain day will occur only 4 times in February. But only if it's a leap year, one of the days will occur 5th time, right? 29th day. So whatever day occurs on the 1st of February will again occur on the 8th, again on the 15th, again on the 22nd, and again on the 29th. So whatever is the 1st of February, the same day will occur on the 29th. That happens only if February has 29 days. So that's what it means. You have to infer from this data. So the 5th Tuesday of February is a holiday. So 29th of February is a Tuesday. And therefore, the 22nd, the 15th, and the 18th, and the 1st, they're all Tuesdays. So if Tuesday occurs 5 times, that means all the other 6 days of the week, they occur only 4 times each. So February can have only 4 Fridays. So how many Fridays does the February have? It can only have 4 Fridays. So using statement A alone, we can answer this question. The 6th of February is a Sunday. Using statement B alone, 6th of February is a Sunday. So therefore, the 4th of February must be a Friday. So Friday, Saturday, Sunday. 4th of February is a Friday. Regardless of whether February has 28 or 29 days, it can only have 4 Fridays. So 4th of February is a Friday. So that means the 1st must have been a Tuesday, right? The 1st of February is a Tuesday, 2nd is a Wednesday, 3rd is a Thursday, and 4th is a Friday. 1st of February was a Tuesday, and the 29th is a Tuesday. So there are 5 Tuesdays. Or at the most there might be 4 Tuesdays. Regardless of whether it has 28 or 29 days, it can't have more than 4 Fridays. That's the material point. So from statement B alone, we can say it can have 4 Fridays, only 4 Fridays. So either statement alone is sufficient. So we pick option 2. So question number 14. Is x greater than y, where x and y are positive? Remember, it doesn't say positive integers, it just says positive numbers. Statement A, x plus y is greater than xy. Statement B, x squared divided by y squared is greater than 1. Using statement A, either x or y equal to 1, or both. But we cannot know if x is greater than y. So the only time you can have, so remember x and y are both positive, okay? So the only time you can have x and y, x plus y greater than xy, is when either x equal to 1 or y equal to 1. So let's say we have x equal to 4. So 4 plus 1 will be greater than 4 times 1. Even if you have 4 times 2, 4 plus 1 will always be less than, 4 plus 2 will always be less than 4 times 2. 4 plus 3 will always be less than 4 times 3. So the moment you have a multiple here, this number increases very fast. Okay, the product. And the sum will always be, increasing at a very slow level, at a very slow rate. So even if you have, say, x and y are, say, 10 and 9. So 10 plus 9 can no way be greater than 10 times 9, which is 90, right? It will always be less than the product. So if you have to have the sum greater than the product, so you have to have one of these numbers as a 1. Let's say, for example, let's take the number to be y. So if y is 1, then we have, x times 1. So x plus 1 will always be greater than x times 1. X plus 1 is always greater than x. And if you have, say, x is equal to 1, so y plus 1 will always be greater than y. So that's the only way this condition can hold true. So either of these numbers has to be 1. And if you have you can't have 0, right? So that's ruled out. And what about like fractions? Suppose you have 0.5. So x plus 0.5 will be greater than x times 0.5. That still holds. So x or y can be 1, or it has to be a number between 0 and 1. Okay, so that much we can infer using this statement A. Okay, but we still don't know which number is between 0 and 1 and which is the other number. So either of them can be between 0 and 1. Okay, and the other number can be anything positive. So we still don't know. So statement A alone is clearly not sufficient. Using statement B alone, is x greater than y? X squared is greater than y squared. So remember, that doesn't mean that oh, I'm sorry, there's a mistake here. So x squared is greater than y squared. It doesn't mean that x is greater than y, okay? Just because x squared is greater than y squared, but they're both positive numbers, right? Remember, if they were negative numbers, there would be a big problem. Just because x squared is greater than y squared, we cannot say that x is greater than y. But we know that they're both positive numbers. Therefore, x squared greater than y squared clearly means that x is greater than y. So using statement B alone, we can answer this question, but not using A alone. So I pick option 1, which is statement B alone is sufficient. Question number 15. Who is Tom's mother? Statement A. So Rita's father is Tom's grandfather. Statement B. Tom's mother has no siblings. So using statement A alone, what do we infer? We cannot say if Rita is Tom's mother or aunt. Rita's father is Tom's grandfather. So remember, Tom's grandfather can be his maternal grandfather or his paternal grandfather. So Rita's father. So Rita could be Tom's mother and Rita's father would be Tom's grandfather. That's one option. But what if Rita is Tom's aunt? So what if Rita is Tom's mother's sister? Even then Rita's father would still be Tom's grandfather. And what if Rita was Tom's father's sister? Her father would still be Tom's grandfather. So we cannot say that Rita is Tom's mother using statement A alone. So she could be either his mother or an aunt. That much we can say. Using statement B alone, we still do not know if Tom's father has any siblings. So Tom's mother has no siblings. So clearly Rita is not a maternal aunt. Rita can either be the mother or she can be the father's sister. So we still don't know if Tom's father has any siblings. Rita could still be Tom's father's sister. But using both the statements together, we still cannot know who Tom's mother is. So both the statements together are insufficient. So we pick option 4. Data sufficiency number 16. Two shopkeepers X and Y have shops adjacent to each other and started with the same amount of investment. Does X make more profit than Y? So X and Y earned the same. Statement A. So what do we know? Two shopkeepers X and Y adjacent to each other started with the same amount of investment. So does X make more profit than Y? So remember the equation. Earnings, whatever revenue they get, minus the costs, the expenditures of running the shop, minus the cost, minus the investment is the profit. So we know that both had the same investment, but what do we know about their costs of running the shop? There may be two different types of shops. Like one shop might require a lot of cost to run. So maybe one shop is really big, the other one is small. He has to pay more rent. Or maybe one shop is employing more salespeople, the other one needs only one salesperson. So we don't know those details. We don't know how much they're spending, right? Expenditure, cost of running the shops. So that's what we have to find out from the statements. Statement A. X and Y earned the same total amount in their respective business this month. So from statement A, we know that X and Y had the same earnings. Their revenue was the same. So they invested, let's say, 1,000 rupees per head to start this business. And both of them made a revenue of, let's say, 8,000 rupees. So we only know that. But we don't know how much they spent in costs of running the shop. So statement B alone. X's cost of running his shop is more than Y's cost. So here it says X spends more money to run his business. So investment is the same, earning is the same. So X has more costs, so deduct more costs. So he has less profit. And Y has less costs, so more profit. So clearly Y makes more profit than X. Using both the statements together, we can answer this question. So even if you try to use B alone, their costs are different, but if you don't know their earnings, you still can't answer the question, right? So you have to have both these statements together and then you can answer the question. So we pick option 3. Question 17. Find the 2-digit number. The number is a prime number between 40 and 50. And statement B, the tens digit is 4 times the unit digit. So using A, the number may be 41, 43 or 47. These are the only 3 prime numbers between 40 and 50. Using B, the number may be 41 or 82. So tens digit is 4 times the units digit. So it can only be 41 or 82. If the units digit is 3, then it would be 12, which would make it a 3-digit number. So it can only be 41 or 82. It can't even be anything ending in 0, right? Because any time 0 is 0. So, but using either statement alone, we cannot arrive at a unique solution. But if you use both the statements together, from these two sets, we see that 41 is the only number that's common. So 41 is the answer. Using both the statements, option 3, we can solve the problem. So option 3. So question number 18. Find the HCF of two numbers X and Y. Statement A. The LCM of the two numbers X and Y is 120. Statement B. The LCM is twice one of the numbers. Using A alone, LCM of these two numbers is 120. So what does that mean? The numbers may be, for example, say 12 and 40. Their LCM is 120. 30 and 40, their LCM is 120. 40 and 60, or any factor of 120 and 120. So any of these numbers can have their LCM as 120. So we can't arrive at a unique solution using A alone. Okay? So using B alone, it says the LCM is twice one of the numbers. So using B alone, we cannot solve it either. But using both the statements, okay, together, then what can we get? So LCM is twice one of the numbers. So one of the numbers must be 60. So one of the numbers is 60. What can the other number be? So that their LCM is 120. LCM of 60 and 120 is 120. LCM of 60 and 40 is also 120. LCM of 60 and 24 is also 120. So we still don't know what the other number is. Okay, so these are some possible solutions. Suppose you had the numbers as 60 and 40. So what would be their HCF, highest common factor? Their highest common factor would be 20. Suppose the numbers were 60 and 120. Their highest common factor would be 60. So I'm saying we can't arrive at a unique solution. So even using both the statements together, we cannot determine the HCF of X and Y. So I'm sorry, it says 3 here, but actually the answer is 4. So it means both the statements are insufficient. So there's a mistake here, the option is 4. So question number 18, answer 4. I'll make a note to change it in the PowerPoint. So both the statements together are not sufficient to answer this question. Question number 19. What is the distance between the towns X and Y? Statement A. The distance between the towns X and Z is 3 kilometers and between the towns Y and Z is 5 kilometers respectively. So we know the difference between XZ and YZ. Okay? But we don't know the difference between X and Z, X and Y. So statement B. Towns X, Y and Z form a right angle triangle. So using A, we cannot determine the distance between X and Y. So there's a point Z here somewhere, and X could be here and Y could be here or Y could be here. We don't know the distance between X and Y. So X, Y and Z form a right angle triangle. But we still don't know which is the right angle. So if Y is the right angle, then we have X here, Y here and Z here. So it would be, XZ is 5 and, and then YZ is 3, but we still don't know that. And if you had Z as the right angle, then we would have ZX is 3 and ZY is 5. And the hypotenuse would be XY. So suppose Z was the right angle, then X and Y would be the hypotenuse of the right angle triangle. And suppose X or Y was the right angle, then XY would be one of the sides of the right angle triangle, not the hypotenuse. So we still don't know which one is the right angle. So we still can't say. It might be tempting to think, one side is 3 and the other side is 5 and it's a right angle triangle. So we all know Pythagoras theorem. So 3 squared plus 4 squared is 5 squared, right? So you might be instantly, you might be tempted to think that one of the sides must be 4. So one side is 3, the other side is 4 and the hypotenuse must be 5. So okay, the distance between X and Y must be 4. But that's not true. We don't know whether Z is the right angle, in which case one of the sides is 3 and the other side is 5. So the hypotenuse would be square root of 3 squared plus 5 squared. So we still can't say that. And using both, we still can't determine X and Y uniquely. So we pick option 4. Both the statements together are insufficient. Question 20. Are the points X, Y and Z equidistant from P? Statement A. Px plus Py is twice Pz. So statement B. X, Y and Z lie in a straight line. So using statement A alone, we cannot know if X, Y and Z are equidistant from P. So it says Px plus Py is twice Pz. So let's say there's a point P over here, and there's Px and there's Py and there's Pz over here, okay? So all we know is Px plus Py is equal to Pz. So it doesn't really mean anything. For example, if Px is equal to Py equal to Pz, and they're all like 25 units, for example, even then we could have Px plus Py is twice Pz. Or if Px was 30, Py is 20, and Pz is 25, we could still have Px plus Py is equal to twice Pz. So it doesn't necessarily imply anything about whether they are equidistant from P or not. Using statement B alone, if X, Y and Z are equidistant from P, then clearly P is the center of the circle and X, Y and Z are on the circumference. So if there's a point P and there are 3 points X, Y and Z which are all equidistant from P, it means they're all points on the circumference of a circle, an imaginary circle drawn around in such a way that these 3 points lie on the circumference of the circle. Really, that's what it means. We just have to position them such that, we can draw a circle around them, really, right? So any number of points, if they are equidistant from a central point, P, it means that they all lie on the circumference of the circle and P is the center of that circle. That's what it means. If X, Y and Z lie on a straight line, so clearly they cannot be on the circumference of a circle. It says that X, Y and Z lie in a straight line. So any 3 points which are in a straight line, how can they be on the circumference of a circle? So clearly they are not equidistant from any point P. So if you have a straight line and 3 points on it, you can't find any point from which these 3 points are equidistant. Even if you have a point here and you had like a triangle over here, these two might be equidistant, but this one will not be. So if there are 3 points in a straight line, they cannot be equidistant from any point P. So statement B alone is sufficient to answer this question, but statement A alone is not sufficient. So we pick option 1. Question 21. Is P greater than Q? Statement A, P square plus Q square equals 73. Statement B, P and Q are positive integers. So using, let's look at all the perfect squares less than 73, okay? Up to, say, 73. So we have 1, 4, 9, 16, 25, 36, 49, 64, and 81, right? These are all the perfect squares, just a little above 73. So using statement A alone, 64 plus 9. So P square plus Q square is 73. Okay, they are positive. We don't know if they are integers, but let's say, using statement B alone, it doesn't mean anything. And using statement A, 64 plus 9 is 73, but then we can have P equal to 8 or minus 8, and Q equal to 3 or minus 3, or vice versa. And we may have other options too, other numbers, say fractions, decimals, which might add up to 73. We don't know. There are at least 2 different solutions. Like it can have P is minus 8 and Q is 3. We can have definitely 4 solutions using this. So we don't know whether they are positive integers, but statement B says they are both positive integers. So that means either P is equal to 8 and Q is equal to 3, or P is equal to 3 and Q is equal to 8. So we still have 2 solutions, even though we use statement A and B together. We still don't know whether P is 8 or Q is 8 and the other one is 3. So we don't know which one is greater than the other. So we have 2 options. The numbers can only take the values 8 and 3. And we don't know which one is 8 and which one is 3. So using both together, we can't answer this question. So we pick option 4. What year is it now? Statement A. 5 years from now, we will be in another century. Statement B. This year is a leap year, and 4 years from now, we will not have a leap year. So using statement A alone, it means 5 years from now, we'll be in another century. So the year can be 1896, 1996, 2096, or anything of that kind. But we don't know which exact year, because it doesn't say we'll be in which century, right? So using statement B alone, it means this year is a leap year, and 4 years from now, we will not have a leap year. So you have to remember some things related to leap years. So every 4 years we have a leap year, and when it's the turn of a century, only a year which is divisible by 400 is a leap year. Like the year 1600 was a leap year, and the year 2000 is a leap year, but the years 1800 and 1900 were not leap years. If it's divisible by 100 and not by 400, then it's not a leap year. So remember that. So this year is a leap year. 4 years from now, we will not have a leap year. So the year could be like, say, 1896, 1796 or 1896, for example. Those were leap years. But 4 years after that, so 4 years after that would be 1800 or 1900 or say 2100, and then there would not be a leap year. So we can still have multiple solutions, say 1796, 1896, for example. And here we can still have multiple solutions. And if you use both the statements together, we can still have multiple solutions which meet all the criteria. So option 4, both the statements together are insufficient to answer this question. Data sufficiency number 23. So if PQR is a 3-digit number, is it divisible by 11? Statement A, Q is equal to P plus R. Statement B, PQR is divisible by 10 and P is equal to Q. So using statement A alone, the number is divisible by 11. Example, PQR is a 3-digit number. Is it divisible by 11? So we have the middle digit is equal to sum of the other two digits. That is one of the conditions. I mean, when that happens, the number is divisible by 11. So the number is of the format 121 or say 165, 242, 363, 792. You take any of these numbers where the middle number is the sum of the other two. Try dividing it by 11. Let's say 165, divide by 11. So 11 times 15 is 165. So 121. So 11 times 11 is 121. So anytime, like say a 3-digit number where the middle number is the sum of the other two digits, then it's always divisible by 11. So clearly using A alone, we can answer this question. So using statement B alone, the statement number might be 110, 220, 330, 440, 550, etc. and is also divisible by 11. So PQR is divisible by 10 and P equal to Q. It's divisible by 10. That means the last digit R is 0. And P is equal to Q. So number is of the form, the number can only be 110, 220, 330, 440, 550 up to 990. So all of these numbers are divisible by 11. Right? So either statement by itself is sufficient. So we pick option number 2. Question 24. P and Q are standing in a queue and there are 7 persons in between P and Q, excluding P and Q. So there's a big queue, people are standing, there's 2 persons, P and Q, and there are 7 persons in between P and Q, excluding P and Q. How many persons are there in the queue? Statement A. If we add 3 more people to the queue, the ratio of number of persons in between P and Q to the ratio of sum of number of people in front of P and behind Q will be 1:2. So let's slowly read that again, okay? Statement B. 40% of the total number of people in the queue are behind Q, and the sum of the number of people in between P and Q and in front of P is half the total number of people in the queue. So in such cases, you have to use your scribble pad and draw a diagram and try and count the total number of people in the queue. So you have to find the total number of people in the queue. So let's say we draw a line like this. So P is here and Q is here, and in between there are 7 people. So P plus Q plus 7 is 9, okay? And then X number of people in front of Q, Y number of people after Q, in front of P, and Y number of people after Q. So total number of people in the queue is X plus Y plus 7 plus 2. So X plus Y plus 9. That's the total number of people. So we have to try and find out the value of X plus Y plus 9. Using statement A alone. So what was statement A alone? If we add 3 more people to the queue, so it's clearly added to the end of the queue. The ratio of number of persons in between P and Q. So we know that the number of people in between P and Q is 7. The ratio of 7 to the sum of number of people in front of P and behind Q will be 1:2. So what that means is sum of number of people in front of P and after Q. So remember, after Q we have Y plus 3, right? We added 3 people. So X plus Y plus 3 is the other factor. So 7 here, and the ratio of 7 to the number is 1:2. So X plus Y plus 3 is equal to 2 times 7. X plus Y plus 3 is equal to 14. X plus Y is 11. So X plus Y is equal to 11. And from that we have to calculate the total number of people in the queue, which is X plus Y plus 9. So 11 plus 9, we have 20 people. So using statement A alone, we can arrive at the total number of people in the queue as 20. Now let's try using statement B alone. 40% of the total number of people in the queue are behind Q. So that means Y is equal to 40% of X plus Y plus 9. Total is X plus Y plus 9. 40% of that is Y, right? So Y is equal to 40% of X plus Y plus 9. So if you solve this equation, you get, so this is 4 by 10, that's nothing but 2 by 5. So you get 5 by 2y equal to x plus y plus 9. So if you take y on the other side, you get 3y by 2 equal to x plus 9. And we have one more part over here. 40% of the total number of people in the queue is behind Q. Using that, we solved something. And the sum of the number of people in between P and Q, so that is 7, and in front of P, okay, that is x, okay. So 7 plus x is half the total number of people in the queue. So 7 plus x is equal to 50% of total number of people in the queue. So 7 plus is equal to 50% of x plus y plus 9. So there's a mistake here, it should be x plus y plus 9. So solving this, we can just plug in the values over here, and you can solve for the total number, that is x plus y plus 9. So you just have to move these things around, and you will solve for x plus y, and you plug it in here, and you can get the value of x plus y plus 9. So either statement alone is sufficient to solve this problem. So we pick option 2, either statement alone is sufficient. So in cases such as these, just draw a diagram and use x and y, and visualize things, it makes it easier. Data sufficiency question number 25. So if x, y and z are the only children of P and Q, so P and Q are the parents, let's say the father and the mother of x, y and z, they are the only children. Do P and Q have twins among their children? So we have to find out if any of these pairs are twins. So statement A, X looks up to her elder brothers for help with the homework. And statement B, Y and Z were born in 2 different years, but both study in the 6th grade and wear the same size clothes. So X looks up to her elder brothers. So X is clearly a female. She looks up to her elder brothers. So Y and Z are her brothers for help with homework. And Y and Z are older than X. Okay? That doesn't necessarily tell us if Y and Z are twins. And just because Y and Z are older than her, it doesn't necessarily mean that it is elder, but yeah, well, if they're born a few seconds apart, they're still twins, right? If they're born a few minutes apart, they're still twins. But it says clearly elder, so they're at least like, a few months older. So clearly X is not a twin of either Y or Z, okay? But Y and Z may still be twins. So statement A is not sufficient to answer this question. Let's look at statement B alone. Y and Z were born in 2 different years, but both study in the 6th grade and wear the same size clothes. It says Y and Z were born in 2 different years. So don't jump to conclusions. Don't immediately say, oh, that means Y and Z are not twins. That's not true, and I'm going to show you. This is where you have to be careful for traps. When it comes to questions about leap years and twins, you have to be very careful. So they're born in 2 different years, both study in the 6th grade and wear the same size clothes. Well, it's possible that they were born in 2 different years. So maybe they're like 3 years apart, and maybe Z is not too smart. Maybe he failed for 3 years, and maybe they're still in the 6th grade. And they may still wear the same size clothes. We don't know. But it's also possible that Y and Z were born just a few seconds apart, okay? Suppose Y was born on December 31st at 11:59 p.m. and the other was born on the 1st of next year at 12:01 a.m. They are still born in 2 different years. They're born like 2 seconds apart. They're born in 2 different years. They celebrate their birthday on 2 different days. And they list it as 2 different years. But they are still twins. So we still can't say if Y and Z are twins or not. They may still be twins, or they may not be twins. So using both the statements, it's still not possible to say if they are twins or not. So we pick option 4. Question 26. Is m a 2-digit number odd? So we have to say if m is an odd number or an even number. Statement A, the cube of m is odd. Statement B, the square of m when added to a 2-digit perfect cube number gives another perfect square number that is composed of the same 3 digits as the square of m. So let's analyze each statement. Using statement A alone. Cube root of m must also be odd. So only an odd number multiplied by itself can give you an odd number, right? If you have an even number, its cube will definitely be even. Only an odd number can have a cube as an odd number, right? So cube of m is odd, then definitely m is odd. Using statement B alone. So m square plus a 2-digit perfect cube. So m square plus a 2-digit perfect cube. So which are the perfect cubes? We're having 2 digits. So there's only 27. That is 3 cube is 27 and 4 cube is 64. 5 cube is 125, right? And 2 cube is 8. So there are only 2 cubes, perfect cubes which have 2 digits. 27 and 64. So m square plus a perfect cube equals n square. It gives another square. And we know that this square number has 3 digits. And it has the same 3 digits as m square. M square is a 3-digit number and n square is a 3-digit number. And they have the same 3 digits. So if you just remember a few of such interesting numbers, we know that 169 plus 27 is 196. So they have the same 3 digits and this one is a perfect cube. So you can just try plugging in different values. Look at all the 3-digit square numbers. So there's 100 and there's 11 square is 121 and 12 square is 144. So it says it uses the same 3 digits, right? So if this was 121 added to something, and it would, if using the same 3 digits, you would either have 211 or 112, and neither of them is a perfect square. So 11 is ruled out. So it's right, 12 square is 144. So added to a cube, if you use the same 3 digits, 144. So either you have 414 or 441, and none of them is like a perfect square. So 12 is ruled out. What if m is 13? So 13 square is 169 plus 27 gives 196. So you just plug in some values and try. So you get these. So there we solved it, right? Using statement B alone, we solved it, and using statement A alone, we could solve it. We can answer the question. So we just have to find if m is odd or not, okay? So in using A, we know that m is odd. We don't have to find the value of m. So don't fall into that trap. So either statement alone is enough. So we pick option 2. So question 27, find the value of xy. Statement A, it says xy equals x squared. Statement B alone, x minus y equals y minus x. So using statement A alone, we cancel x on either side, and we can say y is equal to x. But that's assuming a non-zero value of x, right? What if x is 0? Because 0 times 0 is still kind of undefined, right? Then we wouldn't know, what if x equal to y equal to 0? That's still a possibility. Well, if the question said x and y are non-zero numbers, and then it said this, then we could easily infer that. But otherwise it's a little tricky. So and even if we say x equal to y, we still don't know the value of x and y, right? X minus y equal to y minus x. So if you just take x on this side and y on this side, we'll still say x equal to y. So using both the statements together, we still don't know the value of x or y. So both the statements together clearly are insufficient. So question 28. Find the value of x plus y if 2x plus 7y is 31. So statement A, x and y are integers. Statement B, x is greater than y. So using A alone, x equal to 5 and y equal to 3 is a possible solution, right? X and y are integers. So 2 times 5 is 10 and 7 times 3 is 21. So 5 and 3 is a solution. But we can also have x equal to 12. So we have 24 plus 7. So we'll still have 12 and 1 as another solution. So, and remember, they may be negative integers too. So we have clearly multiple solutions. Statement A alone is not sufficient. Using B, we cannot identify unique values for x and y. X is greater than y. But still we can have multiple solutions, right? So 12 and 1 is 1, 5 and 3 is another one. So both the statements together are insufficient. So option 4. Question 29. If x and y are two single digit numbers, then is their LCM also a single digit number? So statement A, x and y are two consecutive positive integers. Statement B, x and y are both prime numbers. So x and y are two single digit numbers. So is their LCM also single digit number? So if x and y are less than 4, then their LCM is a single digit number, right? Suppose you have 1 and 2, x and y, suppose they are 1 and 2, LCM is 2. LCM of 2 and 3 is 6. But if you have so they are consecutive positive integers. The moment you have 3 and 4, their LCM is a larger 2-digit number, right? So if x and y are less than 4, both of them have to be less than 4. So they are positive integers. So they can only be 1, 2 or 3, right? If x and y are either 1, 2 or 3, then we have LCM as a single digit number. Otherwise it's a 2-digit number. And using B, x and y are both prime numbers. So you can have 1 and 2 or 2 and 3, or if it's 1 and 2 and 2 and 3, then the LCM is a single digit number. Or what if they're both prime numbers, right? So what if they are like, say, 3 and 7? Then its LCM is a 2-digit number, 21. So using either statement alone, we cannot answer the question. But using both the statements together, so they're both consecutive, positive integers and prime numbers. Okay, so how many integers can be consecutive and both prime numbers? You can only have 1 and 2 or 2 and 3, right? Because if you use 3 and 4, then 4 is not a prime number. So even if you use 5 and 6, you can't use that because 6 is not a prime number. 6 and 7, so 6 and 8 are not prime numbers, and then 9 is not a prime number. So you can only have 1 and 2 or 2 and 3. These are the only two sets of prime numbers which are consecutive, single digit. So in either case, their LCM is a single digit. So LCM is 2 here, and 2 or 3 LCM is 6. Anyway, the LCM is a single digit number. So using both A and B, we can say that the LCM is a single digit number. So option 3. Both the statements together are enough to answer this question. Find the ratio of the areas of a square and a rhombus. Statement A. The perimeter of the square is half the perimeter of the rhombus. Statement B. The area of the rhombus is 20 square centimeters. Using statement A alone, side of the square is half of the side of the rhombus. So statement B alone. So the perimeter of the square is half of the perimeter of the rhombus. So for perimeter of the square is nothing but 4 times the length of the side of the square. So let's say if the length of the side of the square is x, 4x is the perimeter of the square. And for the perimeter of the rhombus, if the side is y, it's still 4 times y, right? So this is 4x and it's half of the perimeter of the rhombus. 4x equal to half of 4y. So we say x is equal to half of y. So means length of the square is half of the length of the side of the rhombus. That's all we can infer from statement A. So, but using this, we cannot comment on the area of the rhombus because we don't know the angle of inclination. So it might be inclined at 60 degrees, it might be, the rhombus might also be a square, or the rhombus might be inclined at like 30 degrees or 20 degrees, we don't know. And the area will differ in each case, right? Because the height of the rhombus will be different. So we just know the ratio of the length of their sides. We don't know the ratio of their areas. Using B alone, the area of the rhombus is 20 square centimeters. We cannot determine the length of the sides of the rhombus. So what it means is we can't determine the inclination of the slant. So suppose the side is like 5 centimeters and then the angle is different. The angle might be 60 degrees or 30 degrees and the height might be different. So say 5 times 4 is 20 and the area will still be 20. So if the height was 4 and the base was 5, it would still be 20. If the base was 8 and the height was 2.5, it would still be 20. So we don't know what the dimensions of the rhombus are, right? It might be a rhombus of side 8 or a rhombus of side 5. Like, we don't know, because the height will be different and it can still have an area of 20. So it doesn't tell us anything about the length of the side. So using both together, we still cannot determine the exact length of the side of the rhombus or of the square using both the statements. So we pick option 4. Who among x, y and z runs the fastest? Statement A. Y takes twice the time taken by z to run a mile. Statement B. X takes 50% more time than z to run 20 miles. So let's pick option using statement A alone. Y has a speed half of z. So y takes twice the time taken by z to run a mile. It's the same distance. Y takes double the time. So clearly y's speed is half of the speed of z. That's all we can infer from that. And clearly z is twice as fast as y. Using statement B alone, x takes 50% more time than z to run 20 miles. So x takes 3 by 2 the time taken by z. So z takes only 2/3 of the z. So x takes 50% more time, so x has a speed 2/3 of z. So z is faster than x and z is faster than y. So either statement alone is not enough, but using both together we can say z is the fastest. And so we pick option 3. So question 32. How many days are there in the year PQRS? Statement A. The year is divisible by 4. Statement B. The year is not divisible by 400. So this is a tricky question about leap years. So using statement A alone, the year is divisible by 4. It may be a leap year if it's not divisible by 100. So if it's but it's divisible by 400. So for example, 1800, 1900 are divisible by 4, but they're not leap years. And 1600 and 2000 are leap years. They're also divisible by 4, but they are leap years. Just because it's divisible by 4 doesn't mean it's a leap year. So we don't know the number of days. And using statement B alone, the year is not divisible by 400. So we still don't know whether it's divisible by 100. For example, 1800, 1900 is not divisible by 400, but it's still a leap year. And 1996 is not divisible by 400, but it's a leap year. So it may or may not be a leap year. So either statement alone is not sufficient. Now let's try using both the statements together. It's divisible by 4 and not divisible by 400. So let's take some values. Say 1896, divisible by 4, not divisible by 400. It's a leap year. Let's take the value 1900, divisible by 4, not divisible by 400. and it's not a leap year. So we found two examples. One is a leap year, one is not a leap year. So using both the statements together, we still can't find a unique solution for this question. So we pick option 4. Question 33. Find the value of P. Statement A, P cube equals 9P. Statement B, P is negative. So using statement A alone, P equal to 3 or minus 3. So P square equal to 9. So P equal to plus 3 or minus 3. These are the only two options possible. And using statement B, P is negative. So B alone doesn't mean anything. Using both together, it's negative and it can take the value 3 or minus 3. So it can only take P equal to only minus 3. So using both together, we solve the problem. So we pick option 3. Question 34. Which among these has the greatest area? The square, the rhombus, the circle, or the equilateral triangle? So let's take statement A. The equilateral triangle, square, and rhombus have the same length of side. Statement B. Diameter of the circle is equal to the length of the side of the square. So using statement A alone, area of the equilateral triangle, we know it's like using the formula, it's like root 3 a square by 4. If the side of the triangle is x, so root 3 x square by 4. So square root of 3 by 4 is 0.4338. So it's useful to remember that. So 0.4338 times x square is the area of the equilateral triangle of side x. So the equilateral triangle, square, and rhombus have the same length of side. Area of the square of side x will be x square. Area of the rhombus, it can be either x square or less than x square, because depending on the inclination of the rhombus, at the most it can be x square, and if it's inclined, then it will be less than x square. So the rhombus can have an area at the most x square or less than x square. Area of the square is x square. Area of equilateral triangle is 0.4338 times x square. So statement B alone, diameter of the circle is equal to the length of the side of the square. So area of the circle is pi x square, right? So diameter is equal to the length of the side of the square. So what is the radius of the circle? Half of the length of the side of the square. Side of the square is x, as we thought earlier. So x by 2, right? So pi times x by 2 the whole square. So pi by 4 x square. So pi is 3.14 divided by 4, that is 0.785 times x square. That is the area of the circle. So now we can compare these four figures, right? Using either statement alone, we can't get the answer, but using both the statements together. So clearly the equilateral triangle and the circle are smaller than the square, but we don't know if the rhombus is the same size as the square or smaller than the square. So it's either the square and rhombus are equal size or rhombus is smaller. So if the rhombus and square are equal size in area, then both have the same greatest area, otherwise it's a square. So using both the statements together, we still can't arrive at a unique solution. So we pick option 4. Question number 35. In which month is Mary's birthday? Statement A. The month in which Mary was born is in the latter half of the year and has the maximum number of days a month can have. Statement B. For the month in which Mary was born, the preceding month has 1 day more than the succeeding month. Using statement A alone, the month could be, the month in which Mary was born is in the latter half of the year. So it's, say, July, August, September, October, November, December. So it's one of those 6 and has the maximum number of days a month can have. So that's 31 days. How many months have 31 days? July, August, October, and December. So my dad used to teach me a trick when I was a little girl about remembering which months have 31 days and which months don't. So you start with like the, you hold a fist like this and you say, start with January. So it's on top, right? And then there's the crest and the trough and the crest and the trough. So the ones on the crest have 31 days and the other ones have less than 31 days. So January, 31 days. February, less than 31. That's 28 or 29. March, 31 days. April, 30 days. May, 31 days, and June 30 days, July 31 days, and then you go to the other hand. So August again 31 days, September 30 days, and then you have October 31 days, November 30 days, and December 31 days. So that's an easy way to remember, okay? And so July, August, October, and December have 31 days. Using statement B alone, so month in which we can't arrive at a unique solution using statement A alone. Using statement B alone, for the month in which Mary was born, the preceding month has 1 day more than the succeeding month. So the month can only be August. So only for August, the preceding month has 31 days. And the succeeding month has 30 days, right? Can you think of any other month? Let's say January. Preceding month has 31 days, December of the previous year, and the succeeding month has 28 or 29 days. That doesn't hold. So February clearly doesn't hold. February, so January and March have the same number of days. You see March, February has less number of days than April. So if you see April, so March and May have both 31 days. You say May, so April has lesser number of days, 30, and June has again 30. So if you say June, so May has 31 and July has 31. So if you take July, June has 30 and August has 31. So we want to find the preceding month having 1 day more than the succeeding month. So if you take August, July has 31 days and September has 30 days. So August works. And if you just continue to check for the remaining months, say September, October, November, and December, so you'll see that none of them satisfy this condition. The only month that satisfies this condition is August, because the preceding month, July, has 31 days, and September, the succeeding month, has 30 days. So statement B alone is enough to answer this question, and A alone is not sufficient. So we pick option 1. So how old is Peter? Statement A, Jack is 25% older than Peter. B, 6 years ago, Peter was half as old as Jack is now. So using statement A alone, we get J is 1.25 times P. Statement B alone, P minus 6 equal to J by 2. So P minus 6 is J by 2. So using both the statements together, so P minus 6 is 1.25 P by 2. So if you solve it, you get, J is 20 and P is equal to 16. So you get the age of Peter. So using both together, we can solve this. So sometimes in such questions in data sufficiency, you don't have to actually solve for the actual value of Peter's age or Jack's age, okay? All you have to say is this statement alone enough, or this statement alone enough, or either statement alone is enough, or both statements are required. That's all you need. They're not asking you for the value of Peter's age. All you have to say is you need both the statements to solve. So you don't have to actually, once you plug in the values over here, you can solve it, right? So you don't have to waste time in actually finding the values. So you just say we need both the statements. So pick option 3. That's it. Data sufficiency question number 37. Bill purchased a toy for $500 and sold it after 2 months. At what price did Bill sell the toy? Statement A, Bill's loss amount is 5 times the loss percentage. Bill's actual loss amount is 1/10 of the cost price. So we know that cost price minus loss amount is the selling price, okay? So Bill's loss amount is 5 times the loss percentage. So let's say cost price minus selling price equals loss amount, okay? Using statement A alone, loss amount is So the cost price C is 500, okay? C 500 minus S is equal to 5 times 100 times 500 minus S divided by 500. So it is 5 times the loss percentage. So what is the loss percentage? So it is cost price minus selling price. Loss amount divided by cost price times 100. That's the loss percentage, right? So, I mean, if you just plug in the values here, I mean, it doesn't give a unique loss amount. So it could be that multiple values satisfy this condition. So if the loss was 10%, for example, so $500, 10% loss. What would be the loss amount? 10% of 500, which is $50. Loss amount is $50. Loss was 20%, the loss amount would be $100. So either of these values, for example, would satisfy this condition. And you don't get a unique solution using statement A alone. Using statement B alone, we know that the loss amount is 1/10 of the cost price. We know that the loss amount is 1/10 of the cost price. 1/10 of the cost price is 1/10 of 500, that is 50. So loss amount is 50. So what is the selling price? Cost price minus loss amount. So 500 minus 50, we get 450. So B alone is enough, but not A alone. So we pick option 1. Question 38. A 2-digit number is divisible by 17. What is the number? Statement A. The sum of the digits is a prime number. Statement B. The number is even. So 2-digit multiples of 17. Which are the numbers? 17, 34, 51, 68 and 85. These are the 5 numbers that are 2 digits and multiples of 17. Using statement A alone, the number may be 34 or 85. The sum of the digits is a prime number, right? So 1 plus 7 is not a prime number, 5 plus 1 is not a prime number, 6 plus 8 is not a prime number. So 3 plus 4 is 7, prime number, and 8 plus 5 is 13 is a prime number. So the number can only be 34 or 85 using statement A, but we still don't know which one of these. So statement A alone is not enough. Using statement B alone, number is even. So from these numbers, it's even. So it's either 34 or 68. So we still don't know which one. But if you use both the statements together, it can only be 34. So the sum of the digits is a prime number and it's also even. So it can only be 34. So using both the statements together, we can solve this question. So we pick option 3. Question 39. What is the ratio of Tom's age to his mother's age? Statement A. When Tom was 25, his mother was twice his age. Statement B. When Tom's mother's age is 60% of her centurion grandmother. So using A. When Tom was 25, his mother was twice his age. So his mother was 50. So we don't know currently how old he is, right? So currently we don't know how old either of them is. Using B. Tom's mother, but we know that the difference between their ages is 25 years. That's all we know. Using statement B alone, Tom's mother's age is 60% of a 100-year-old grandmother. So clearly now Tom's mother is 60 years old. So this statement alone doesn't tell us how old Tom is. So we don't know the ratio, right? So don't fall into this trap, okay? So using statement A alone, the moment you see, oh, when Tom was 25, his mother was 50. Oh, so the ratio is 1:2. That's not true. What is the ratio of their current ages? Tom's age to his mother's age. So when he was 25, she was 50. But right now, say Tom may be 50 and she may be 75. So the ratio is different. Or Tom may be 30 and his mother is maybe 55. So the ratio is different, you know, regarding of what, depending on what their current age is. So don't fall into that trap and don't say, oh, it's 1:2, and you don't fall into that trap. So Tom's mother is now